So we are going to start 5.4, sum and difference formulas. You can actually see all of the formulas right here. Oh, 80, you're good. Yeah, that's fine. Okay. So off these formulas, sum and difference, like I got to figure out if I want to add or subtract my angles that I'm taking the sine of. All right, so I've got, for number one, I've got sine of pi halves. And so, okay, I've got to be one of the sine functions here. It's not like the cosines or tangents or anything. And out of my sine functions, I'm either going to add up two angles to get pi 12ths, or I'm going to subtract some angles and get pi 12ths. So I guess here's my thought process is, okay, on my unit circle, I think the smallest angle that I've actually memorized was pi 6. And pi 12ths, like a 12th is less than a 6th. So out of, whether I'm going to add or subtract, I'm thinking I'm probably going to have to subtract to get down to pi 12ths because I don't really know anything smaller than pi 12ths that I could add up. So let's see, I know the pi 6, the pi 4ths I memorized on my unit circle, and pi 3rds. Okay, so out of these, and you can keep going. I can go to pi halves, all of the ones that I memorized. I'm trying to figure out which ones would, I decided to subtract, so which ones would subtract to be pi 12ths. So I know I'm using this formula here. And out of these, let's see, I'm thinking getting a common denominator between the thirds and fourths. I think that would give me a common denominator of 12. So let's give this a shot here. I'm thinking it'll be subtraction, so probably like pi 3rds minus pi 4ths, which, let's see, if I got common denominators here, this would be like, turn it into 12ths. So this is like 4 pi 12ths minus 3 pi 12ths. And oops, let's see, 4 minus 3 is 1. That gets me to my 1 pi 12ths. That's what I'm going for. So yeah, I think I'm going to do the pi 3rds minus the pi 4ths. All right. So let's see here. All right. So on my, I'm going to set this up real quick here. My u, it looks like, in the equation I'm going for. Come on. All right, the u I'm using is pi 3rds minus the v I'm doing is pi 4ths. All right, and according to this formula, that's going to give me sine of u. So sine, oops, come on. Let's see if it'll let me write today. Come on. So sine of my u, which is pi 3rds times cosine of my v, which is pi 4ths. And then minus cosine of the u, which again, u is pi 3rds, times sine of v, which the v was pi 4ths. Okay. So I think we know sine and cosine of all of these angles. So let's see, my sine of pi thirds. Up here, my sine, my y value is √3/2. Okay. If it lets me write, that would be nice. Okay. All right, times my cosine of pi fourths. The cosine at pi fourths is √2/2. And then minus cosine of pi thirds. Cosine at the pi thirds, like the x value at the pi thirds, is a 1/2. So we did have to memorize our unit circle. All right, times the sine of pi fourths, which sine of my pi fourths is a √2/2. All right, so it's looking like I'm going to get, let's see, √3 times √2. I'm going to put it all under a square root. So I'll get a square root of 6. Again, I'm just kind of putting it all together. So square root of 6 over 4. Again, my 2 times 2 gives me that 4. And then minus, I've got a √2 times 1 is still √2. All right, over 4, there we go. And I think they'll probably, on your homework, they'll probably condense it down into a single logarithm. Or sorry, not logarithm, I don't know what I was coming with that. Single fraction is what I'm going for. They'll probably end up putting it a √6 minus √2 and then all over 4. I think they usually write it like this, but yeah, there we go. How are you guys doing on this one? You okay with this first problem? Yeah, we're doing all right. Okay. All right, let me know if you guys have questions. You guys are here today, so let me know what you got. Okay, so I'm going to move on to number 2, where you find the exact value of cosine this time. Cosine of 75 degrees, so it's got to be one of these two, either cosine of 2 angles added up or cosine of 2 angles subtracted, but I don't know what the cosine of 75 degrees was. Like the stuff that I memorized on my unit circle, none of it was 75 degrees. All right, so as far as those that I memorized, if I'm going to do this in degrees instead of my radians, I'll put this in green in degrees. All right, so I'm going to put those same spots on my unit circle, but just in degrees. This would be my 30 degrees, my 45 degrees, and 60 degrees. Okay. So again, I have to figure out, am I going to add stuff up to 75 or am I going to subtract them? And I think personally, I'm like, okay, I'm going with the 45 and 30. That adds up to 75. So for that reason, let's see, I'm going to use the sum formula. This guy, I'm going to add them up. All right, so according to that formula, I've got to do my cosine of u, cosine of v. Let's identify what the u and the v are actually. So if I'm doing the 45 and the 30, in addition, order actually doesn't really matter in addition. I don't care if we do cosine of 30 plus 45 or 45 plus 30. Either way, I'm going to get to the 75. Okay, on the subtraction one though, this one up here, the order did matter. Okay, so according to this formula, I'm gonna go with cosine. If it lets me write, that would be great. All right, come on. Goodness gracious. Oh, it's letting me write, hallelujah, okay. So the u in this case is the 30, the v is the 45. So I'm going to do cosine of u, so cosine of 30 degrees times the cosine of the v, the 45 degrees, minus sine of the u, which u was 30 degrees, and then sine of the v. Sine of the v was 45 degrees. Okay. All right, so I think we should know these from our unit circle. Again, 30 degrees, we should know the xy point here. This will give me my sine and my cosine. So the xy point being root 3/2 for my x and a 1/2 for my y. At 45 degrees, I've got root 2/2 for the x and the y. So that essentially tells me my cosine and my sine for each of those angles. So cosine at 30 degrees is the x value at 30 degrees, so root 3/2. Come on. All right, times my cosine of 45 degrees, and the cosine is, again, the x value, and the x value at my 45 degrees was root 2/2. So I'm multiplying by root 2/2. Minus sine of 30 degrees. Sine is now the y value. The y value at my 30 degrees was 1/2. And sine of 45, so the y value at 45 degrees was a root 2/2. All right, so I will simplify these down. Again, my root 3 times root 2, I'm going to put it all in a single square root, so I'll put it into a root 6. Minus 1 times root 2 is root 2. And then they actually do have common denominators. They both have a 2 times 2, a 4 denominator. So this is all over 4. Okay. Over 4. There we go. So here is our final answer. And again, online on your homework, if they tell you, round to the nearest hundredth or whatever, then that probably means put it in your calculator, get a decimal, and round it. If they didn't tell you to round, it's probably because they want the exact answer like this. All right, any questions on this stuff? So Audrey, I just chose those because I needed them. I chose the first quadrant because I was looking for angles that would add up to 75. So I definitely didn't want to use something over 90. I could, if I wanted to though, I guess I could do like a, I don't know, if I could find some huge angles that subtract down to a 75, I could, and I should get the same exact answer. That's true. Yeah, no problem. Yeah, you should, if you chose different angles, should be able to get the same answer. All right, so good question. Let's look at number 3 here. So find the exact value of sine of u plus v, which we know the formula for sine of u plus v. So given that your sine of u is 4/5, where the u is between 0 and pi halves, and then your cosine of v is negative 12/13, where your v is between pi halves and pi. All right, so first things first, they're telling me I've got to do sine of u plus v, and my formula for that was sine of u not plus, sorry, sine of u times the cosine of v plus my cosine of u sine of v. All right, so that's my formula for that. And they actually gave me a couple of these. They said sine of u is 4/5. So this guy right here, 4/5 times, I don't know what the cosine of v is quite yet. They didn't, oh, they actually did give me the cosine of v, just kidding. Cosine of v is this guy, the negative 12/13. Nice, but I do know the sine of u. I don't know the cosine of u though. I don't have that quite yet. So this is where I'm at so far. Sine of v, I got the cosine of v, but I don't know the sine of v quite yet. All right, so here's where I'm at so far. I need to get some information for these other trig functions. So what I'm gonna do is, I'm gonna put this on my unit circle. They told me like which quadrant I was in when they said that my u is between 0 and pi halves. Let's see. I'll try to color coordinate this here. U is between 0 and pi halves, so my u is in the first quadrant. All right, so it's, here we go, there's my right triangle with sine. So katoa, sine is the opposite over hypotenuse, and they give me a 4/5, so the opposite is a 4, and the hypotenuse is a 5. So that means if I can find this missing side, I can get any of the 6 trig functions that they want. And this again was for the angle u, and put a little u here, if I can. All right. Let's see if it'll let me, come on. Okay, so here's my angle u, my 4/5. If you do Pythagorean theorem, does anybody actually remember a Pythagorean triple that this works with? Like, would you guys automatically know what your third side was? Do you guys know a Pythagorean triple with a 4 and 5? If not, that's fine, but. Oh yeah, that totally works, Dylan. Yeah, so you did Pythagorean theorem, you did your, like, a squared plus b squared equals c squared. So let me write this. Come on. All right, next you subtracted your 4 squared over. So then I'm going to take a square root, and I'm going to get, now when I take a square root, it's like a plus or minus, right? Plus or minus 3. But because I'm in the first quadrant, I've got to have a positive x value. So this has to be a positive 3 on this triangle. All right. So that was for my angle u. Let's take a look at this angle v here. So angle v, if I give it its own triangle then, they said it's between pi halves and pi. So that means I'm in the second quadrant. So I'm gonna draw my little triangle here in the second quadrant. All right, so that kind of makes sense why it's a negative cosine. I've got like negative x values in the second quadrant. Here's my negative 12. There's my adjacent over hypotenuse. All right, so for angle V, I've got 2 sides again. We're gonna have to find our missing side, which this y value should end up being a positive y value in the second quadrant. All right, so I'll do my Pythagorean theorem again. A squared plus b squared equals c squared. Come on. So let's see, I got a 144 plus my b squared equals 169. So if I subtract it over, my b squared is equal to 25, which I think we know the square root of 25. And again, I would have to put a plus or a minus and kind of consider whether it would be a positive or negative. And I think we already talked about this. That is a positive y value in the second quadrant. So I'm going to go with a positive 5. And because I've labeled both of these triangles, I can actually find the missing trig functions that I had so far. So let's see, I was missing cosine of u and sine of v. So cosine of u, cosine is adjacent over hypotenuse. So my cosine of, here's my u angle, cosine adjacent over hypotenuse is going to have to be a 3/5. Okay, so this one's actually a 3/5. If it lets me write it. Okay, 3/5 that we found off of that triangle. And then times my sine, which is the opposite over hypotenuse, and on this V triangle that we found, the opposite is a 5 over the hypotenuse 13. Okay. So I still have the first ones that they gave me right off the bat. They gave me the 4/5 and they gave me the -12/13. Okay. So now I'm down to all numbers. I can get a final answer here. It looks like I will have common denominators. It looks like I've got a 5 times 13 on both of these fractions. So I got like a, what, 65 on both of those. So I have a common denominator of 65. Let's see, the numerators. This one over here, I've got a -48 plus, and then this is going to be a 3 times 5, so plus 15, means I'm going to end up with a -33/65. So it lets me write this. Okay, so there's my final answer. I just had to do this little extra work. I had to look at 2 different triangles to find the blue and the yellow. I had to get those extra pieces of information to actually plug into my formula. Okay, any questions on number 3? You guys doing all right on number 3? Nice, thanks, Audrey. Brett, Dylan, Ethan, you guys good? Francisco, Justin, Kaylee, Elena, we good? Thanks, Dylan. Francisco, Justin, thanks, guys. All right, if we're good, I'm gonna move on then. So number 4, this one, it says write cosine of arctangent 1 plus arc cosine x as an algebraic expression. Okay, if they want me to write it as an algebraic expression, I think that's going to be a little different than 1, 2, and 3. 1, 2, and 3 they all ended up as like straight up numbers. There was no variable in there. So that was like an exact value, not an algebraic expression. All right, so I'm thinking when they say write it as an algebraic expression, I'm going to end up with some, they started with x's, right? I'm going to end up with some x's in my final answer here. All right, so what I have to keep in mind is that arc, sine, arc, cosine, any of these arc trig functions, they're the inverse where they give me an angle. So this really is like my cosine of some u angle. This is like some u plus v. Those are my different angles. So let's see, arctangent of 1, I actually can find that on my unit circle. So yeah, if I call this my u, tangent is 1. Keep in mind, tangent is sine over cosine, so as long as my sine and cosine are the same thing, I get a 1. And I think that happens at 45 degrees or pi-4 radians. So that means I know what my u is. This is a pi-4. The v, let's see here, arc cosine of x. Okay, that one doesn't say arc cosine of any particular number. It's a variable x. So I'm going to have to do a little work on that. So for my v, let's consider a triangle here. All right, so for my angle v, cosine is adjacent over hypotenuse. I'm going to treat it as like it's arc cosine of x over 1. So my adjacent would then be the x, and the hypotenuse would be the 1. There's my adjacent over hypotenuse. And I'm going to have to do kind of like I did on number 3, where I got to find this missing side, and then I can find whatever trig functions they want. So let's do some Pythagorean theorem on this. We've got some, let's see, a squared plus, I'll treat this as a b for now, plus b squared equals c squared. All right, so to get that b side that I don't have, let's see, I'm gonna have to subtract my x squared over. Are you guys okay if I say 1 instead of 1 squared? 1 squared is 1. And I'm subtracting the x squared over. And then I'll have to take the square roots of both sides. Okay. So this b here, I'm going to erase that b, and I'm going to replace it with what the b equals, which was my square root of 1 minus x squared. Okay. So now it'll be in terms of x, but I really could find whatever trig function they want in terms of x. All right, so this is, let's see, this is a cosine of the sum. They're adding up their two angles here. All right, so that formula was going to be cosine of u times cosine of v. And then we've got minus sine u sine v. So just should let you know where I'm getting that from my formulas up here, like the one that I circled. Cosine of u plus v is my cosine u cosine v minus sine u sine v. And I was using that one on here because I had the addition in my cosine, so I was doing the sum. All right, so let's see here. My cosine of u, well, we know that u is pi-4. So cosine of pi-4 is root 2 over 2. Cosine of v, the cosine of v, the adjacent over hypotenuse on my v right here, adjacent over hypotenuse would be x over 1. Okay. And then minus my sine of u. So again, on my u, on my pi-4, sine of pi-4 is root 2 over 2. Okay. And then sine of v. All right, this is where I've got to do on my v triangle here. Sine is opposites over hypotenuse. So it is the messy square root over 1. Okay. So I think both of these denominators, they have common denominators already, 2 times 1, so they both have a denominator of 2. The numerator, though, it looks like I have a root 2 times the x at the beginning there. Make sure your x is not under the square root. And then they also have to subtract these guys multiplied together. Now, both the 2 and the 1 minus x squared are under a square root. So I could treat this like 2 times 1 minus x squared. Come on. There we go. I could treat that all under like a single square root, which I could even simplify a little further. Root 2 times x minus, if I distribute that 2, I can get a 2 minus 2x squared. Okay, so here is my final answer. It still has a bunch of x's in it, but their instructions said to have an algebraic expression, which made me think there's going to be some variables. It's not going to be straight up numbers. Okay, so there's my final answer. Do we have any questions?
Yeah, can you go back up, please?
Yeah, which part are we looking at? Can you see what you're looking for? Oh, Audrey, so, okay, as far as simplifying this square root, oops, the square root, simplifying the square root, what I cannot do, say this is not equal to the square root of 1 minus the square root of x squared. If you separate it like that, that is not equal. Is that
what I was actually talking about earlier, I sent that when you were trying to find like the x squared plus b squared equals 1 squared. I was wondering why you couldn't keep the 1 squared and then just when you square rooted all of them, just have it be 1 minus x.
So same thing, because when I take the square root on this, I cannot do the square root of each of them individually. I can't do the square root of 1 squared and the square root of x squared. I can't do that. I have to do the entire side of the equation. I have to do the entire, yeah, that's a 1 squared, that's true. But I had to do the square root of the entire 1 squared minus x squared all together, and I cannot distribute it to each individually. Is that what you're talking about?
Yeah, thanks.
Yep. All right, good questions. You guys have anything else for me? Good, okay. All right, so I'm gonna go on to the next one then. Number 5 here. Verify the cofunction identity. So this actually is one of the identities that I put on your identity sheet for you. And we have to, it says verify, show that it's true. And so the reason they want us to verify this is because it matches our difference of cosine. This is our, let's see, they've got cosine of 2 angles subtracted, right? So that would be, let's see, get rid of these guys. Cosine of 2 angles subtracted. Okay, so we have a formula for that now. So I'm gonna use that formula with, let's see, pi halves for my u and x for my v. Okay, so that formula, I had to do cosine of u. So in this case, right, that would be cool. Cosine of my u is pi halves. and then cosine of v, which my v is the x, okay? And then plus sine of the u, so sine of pi halves, times sine of the v, which is sine of x. All right, and then these two we should be familiar with. Those are pi halves on our unit circle is up at this point, and that is the point 0, 1 on my unit circle. 0 being the x value, the cosine. So this cosine right here, that's a 0 times my cosine of x. Plus, let's see, sine of pi halves, sine is the y value. So my y value is a 1 times the sine of x. All right, and 0 times whatever, this is 0, this is gone. 1 times sine is just sine, so sine of x, there is, I just proved that it equals the sine of x on the other side there. We're just using the formula that we learned today. All right, any questions on number 5? Agree with that one? Okay. All right, all right. All right, I think I've got 2 more. Number 6 here. Write the expression, so cosine of theta minus 3 pi halves. I'm gonna look at my formulas again. I've got cosine of 2 things subtracted. So let's see, out of my formulas, I'm probably gonna go with the same one we just used, right? Cosine of 2 things subtracted, holy crap. Okay, whatever I underlined there. Okay. So it says, as a trigonometric function of only theta. So they pretty much want me to do kind of like I did on number 5. Number 5, I got it down to a trig function with just my sine of x, like with just the variable x. And so now I'm going to go down to only theta. So very similar to what we just did. Okay, so according to this, it was the same formula and everything, actually. So cosine of the u, in our case, theta, times cosine of the v, which in this case is 3 pi halves. And then plus sine of the u, which we had a theta for u, and sine of v, which was our 3 pi halves. Okay, now these two we should be familiar with. 3 pi halves on our unit circle here. Let's see if I can draw where that's at. And again, very similar to what I did on the last problem. 3 pi halves is down here on my unit circle. This is the point 0, -1. All right, so this gives me cosine of theta, which I don't know what the cosine of theta is, but cosine of 3 pi halves. Cosine is the x value out of that point, which was 0. That x value was 0. Plus sine of theta times sine of 3 pi halves, so the y value on this point was -1. Okay, so times a -1. All right, again, 0 times whatever is still 0, and this multiplies to be a negative sine of theta, very similar to what I had before. Okay. Any questions on number 6? So you guys go 5 and 6, very, very similar. So any questions on 5 or 6? Nothing, we're good. All right. So last one today, number 7. So this one says find all solutions of, I think I've got two different formulas going on here. Let's see here. I've got sine of two things added, and I've got sine of two things subtracted. So I'm gonna have to use two separate formulas. And they said on the interval 0 to 2 pi. We saw some of this yesterday. When they tell me from 0 to 2 pi, like one full circle, I'm not gonna make it repeat over and over and over again. You're just gonna go around the circle once and get a limited amount of solutions. All right, so out of these two identities that we've got here, let's do the sum, like I'm adding some angles in my sine. So let's do that one. All right, so that one, again, you can look at this up at the top. That was my sine of u, so my sine of x, times cosine of v, so cosine of pi fourths. All right, and I'm gonna go with the same sign here. I'm gonna do addition still. Plus, all right, and then I've got cosine of the u, my first angle, x, and then sine of my second angle, v, so it's pi fourths in this case. All right, so that was just the first sign. That was just that guy. We then have to, so we've got a big plus sign right here. We got to add on the second one. So our second one is sine of two angles subtracted. All right, so again, I'm going to use one of the identities that I have at the very top. So that identity at the top was going to give me a sine of my first angle. I think it's going to be pretty much similar to what I just did. It just is going to change the sign in the middle. So like instead of adding, I'm going to have subtraction because it was sine of two angles subtracted. But it'd be very similar to this. All right, so let's see, sine of x, my first angle, cosine of my second angle, pi fourths. Okay. Scoot this over here a little bit. All right, and then again, I'm going to change the sign now. It's subtracting now. So subtract my cosine of the first angle x and sine of the second angle pi fourths. Okay. Now this is supposed to equal a -1. All right, but we have to simplify this down quite a bit here. All right, actually, I think this will simplify down rather quickly because here's what I'm seeing. I'm seeing sine of x cosine of pi fourths, sine of x cosine of pi fourths. I've got two of the same thing. So I'm gonna say I've got two of the sine x cosine of pi fourths. All right, and then these guys, I've got a cosine x sine of pi fourths, then I've got a negative cosine x sine of pi fourths. They're really messy, but I have a positive and negative of the same thing, so really those add up to 0. Like, yeah, those add up to 0. I don't need to have those again. And then this is all equal to -1. So that like really long equation got brought down to this one little piece so far. Are you guys okay with how I simplified it down? We're good, okay, nice. All right, so then as far as solving for the x, the nice thing is I have a single x. That's good, I need to start moving stuff over. I've got, let's see, I'm gonna divide my 2 over. Come on, okay. Also, cosine of pi fourths, that's actually one of the points on our unit circle that we should have memorized. Cosine of pi fourths is a √2 over 2. All right, so here's what I'm thinking. These both have a denominator of 2. I'm gonna multiply by 2 on both sides. lets me, and kind of get rid of those denominators on both sides. No more fractions. I like it better that way. All right. And then I also need to, let's see, I'm going to divide by √2 on both sides, which hopefully this looks familiar. We didn't like to have square roots in the denominator. So I'm going to rationalize the denominator. I'm multiplying by √2 over √2 to break this down into negative √2 over my nice whole number 2. Okay. So I'm trying to solve for x, which this x should be an angle. Sine of some angle equals a negative √2 over 2. Specifically, they told us we had to stay between 0 and 2 pi. So like I have one rotation on my unit circle, one full circle. I should see where my sine, which sine are the y values on my unit circle, and I need the y value to be a negative √2 over 2. All right, so then it looks like that'll hit in the 3rd and 4th quadrants. All right, and again, we should have this rather memorized. I'm thinking we've got 5 pi fourths in the 3rd quadrant and 7 pi fourths in the 4th quadrant. And they only wanted me to go around the unit circle once. So these are my 2 solutions. All right, the x equals these 2 angles. All right, and there's my answer. The nice thing about these is you can totally check your answer. You can, because they gave you this equation at the very beginning that was supposed to all equal 1, as messy as it is. It was supposed to all equal 1. So if you guys aren't sure, you can take this and plug it into the original problem and see if it all equals a negative 1 or not. So that's kind of a benefit on these kinds of problems. Any questions on this? This is our last one. You guys have any questions at all for me to answer for you? These are totally good. All right. All right, so I am going to post this online, post the video online, and everybody needs to finish this 5.4 assignment by our first day back after Christmas break. Okay, that Monday after Christmas break, we need to have this assignment done.
So
All
it's
right.
the day after Christmas. Oh, after the New Year.
Yeah, what is it? January, what is that we have to, let's see here, that is, yeah, January 4th. So it's got to be done by January 4th. Okay.
All right, thank you so much.
Yep.
Have a great break. I'll see you.
You too. Bye, guys. Merry Christmas. Hope you guys have a good break.
Bye.
Bye, guys. And Justin, yeah, I can, let me get this video stopped and then I can look at that for you.